This is problem number 4 from section 310. In this problem it says a 25-foot ladder is leaning against a house when its base starts to slide away. By the time the base is 24 feet from the house, the base is moving away at a rate of 7 feet per second. What is the rate of change of the height of the top of the ladder? At what rate is the area of the triangle formed by the ladder wall and ground changing then? At what rate is the angle between the ladder and the ground changing? So we only know really one constant in this problem. That's the ladder's length. That's 25 feet right here. We know that this is, we're going to call this x. They have it x of t here. And this is y. This is y of t. So we can figure out, based on the information they've given us, what the x and the y values are at the specific time the ladder's falling. So it says by the time the base is 24 feet from the house. So they're saying that this is 24 feet. The base is moving away at a rate of 7 feet per second. So that's dx over dt. That's the base moving away at 7 feet per second. So when this is 24 feet away, the base is moving away at 7 feet per second. I'm going to say that's positive because it's moving to the right. Well, we don't know what the y value is here. What's the height when the base is 24 feet away? Well, we can use the Pythagorean theorem to find y. So let's start by saying 24 squared plus y squared equals 25 squared. Well, we subtract some stuff over. We have y squared equals 25 squared minus 24 squared. We take the square root, we get y equals 25 squared minus 24 squared. And let's put that in the calculator. And we end up with 7. So this is 7 here. So that means the height here is 7. So in this scenario that they're having us look at, when the ladder is falling, at the point when x is 24 feet, the y value is 7 feet, and the ladder is falling away at 7 feet per second, we don't know how fast it's dropping. That's what they're asking us for. So they're asking us for dy over dt. So some of the things we're going to find in this problem are dy over dt. We want dA over dt, which is the derivative of the area with respect to time. That's what they ask you for in the second part, right? At what rate is the area of the triangle formed by the ladder wall and ground changing? And then finally, d theta over dt. So we've got 3 things we want to find. Let's start with the easiest one, dy over dt. So to find dy over dt, I think what we want to do is take the Pythagorean theorem now and then take the derivative of it. So we're going to say x squared plus y squared equals 25. And we're going to do the derivative of this with respect to time. And the reason I'm using this is because that's the Pythagorean theorem works for triangles, and we have a triangle made here. And we have d over dt of x squared. Remember, this is going to be with respect to time, so we're going to have implicit differentiation. So we have dx, and this is 2x, and this is dx over dt, plus 2y dy over dt, and derivative of 25 is 0. Now we can plug in some stuff that we know. We know that in this situation, y is 7, x is 24, and dx over dt is 7 feet per second. So let's plug all this stuff in. So we're going to say 2 times 24 feet times dx over dt, which is 7 feet per second, plus 2 times y, which is 7 feet, and dy over dt is what we're looking for, so times dy over dt equals 0. Let's subtract this over, so we have 2 times 7 feet dy over dt equals, this will be 2 Well, let's do 2 times 24 and then times 7. So let's see, 14 times 24. 14 times 24 is 336. So we're going to have 336, and this will be negative 336. And this will be feet squared per second. And now we'll divide by 14 feet essentially. So we have dy over dt equals negative 336 feet squared per second divided by 14 feet. And we get 24. So this is falling at a rate of negative 24 feet per second. So the dx over dt, this ladder is moving outwards at 7 feet per second, but it's falling much faster than it's moving outwards. That's what that's telling us there. So now, let's go ahead and look at the dA over dt. Well, to figure that out, we need the area of the triangle. And we know area is 1/2 base times the height. So I'm going to say area equals 1/2 base is x times the height, which is y. And now we'll take the derivative of this. And when we do that, we're going to have derivative of a, which is dA over dt. We're going to have 1/2. Well, we're going to write this out. U equals 1/2 x. U prime, we got a product rule, by the way. This is x times y, so it's a product rule. So this is 1/2 for u prime. And then v is y, and v prime. And I should say this is 1/2 dx over dt. And this is dy over dt. So let's go ahead and throw that in. We're going to do these two multiplied, so that's 1/2 y dx over dt. And then we've got u times v prime, which will be 1/2 x dy over dt, so plus 1/2 x dy over dt. Now we can start plugging some stuff in because I'm looking for this dA over dt. I have all my information now. I can say 1/2 times y, which we know y is 7 feet, times dx over dt, which dx over dt is 7 feet per second, plus 1/2 times x, which is 24 feet, times dy over dt, which we just found to be negative 24 feet per second. So now we can plug all that in, and when we do that, we should end up with seven times 0.5. So we got 24.5 here. And this is feet squared per second. And then we have 24 times negative 24 times 0.5 minus 288 feet squared per second. And we subtract those and we get negative 263 feet squared per second. Oh, 0.5 feet squared per second. So that means the area of the ladder, so remember this area, as the ladder falls, right, the area is getting smaller and smaller. It's going to eventually, when it hits the ground, the area is 0. That area is falling at, or changing at negative 263.5 feet squared per second. We got one other thing to find, and that's d theta over dt. So it's the last thing we need to look at. We know that the angle here between the x and 25-foot ladder here is, well, we don't know what the angle is, but we know that the ratio between, I should say, this angle and either this side and 25 is cosine. We're going to use that cosine function, or we're going to use sine for 7 feet and the 25. I'm going to go ahead and use sine. So I'm going to say sine theta equals, let's go y over 25. This is how we can start. That we know that this ratio here, opposite over hypotenuse, is true for this specific snapshot of the ladder falling. We can do the sine inverse on each side, and we end up with, if we take the sine inverse of this side, that'll give us theta equals sine inverse of y over 25. All right. Now, I want to take the derivative of this whole thing because I need to find at what rate is the angle changing between the ladder and the ground. So I'm going to do d over dt of theta equals sine inverse of y over 25. So as I go through and work on this here, the derivative here, that's just going to be d theta over dt equals, and I'm going to pull out a formula that we've used for a derivative inverses, trig inverses I should say, and we know that d over dx of sine inverse of u is equal to u prime over root 1 minus u squared. And that should be in your formula list. So we just need to take this piece, sine inverse, and use the sine inverse to figure this out. So u prime, well, the derivative in here is just going to be 1/25, and this is implicit, so that's going to be dy over dt over root 1 minus u squared, well, that's just y over 25 squared. So now I just need to plug in my values. So I've got 1 over 25 times dy over dt, and dy over dt is negative, where's it at? Right there it is, negative 24 feet squared, or not feet squared, feet per second, so negative 25 feet, negative 24 feet per second, over, and then the bottom we have root 1 minus, let's see, y value is 7, so we'll end up with 7 over 25 squared. So d theta over dt, and I'm just going to write it right here because I'm running out of room. When we put all that in the calculator, d theta over dt is going to give us negative 1 degree, and I think we're going to have this in degree per, do I have this per second? Yes, degree per second. So plug all this in the calculator and you end up with negative 1 degrees per second. So what we found in this problem is we found the dy over dt, so the change in the y value, the height, is going down 24 feet per second. The change in the area is going down 263.5 feet squared per second, and the change in the angle of the ladder is going down 1 degree per second.